Our next speaker is Carle Pieters, whom you all know. And as Amy mentioned, she is co-chair of the CLOC-SAT, and we're super excited that this is the coming out party, if you will, for CLOC-SAT, for the draft report. So Carle, please.
Well, so just use the arrow key right there.
Okay, gotcha. Yeah. Thank you. Okay, good morning, everyone. When Amy first got Ben and I together to address what should be the next orbital capabilities, in our first conversation, we said, well, we really need more. It's not just LRO. We need a whole strategy for going forward. And very quickly that became CLOC-SAT, Continuous Lunar Orbital Capabilities. And we're very happy with that. And I like Amy's symbol for us. Okay, let's move on. As Amy alluded to, of course, one of the things that was probably on many people's mind, because we've relied on LRO for more than a decade. And it's still going, thank goodness, but we need to plan for the future. And that's essentially what CLOC-SAT's task has been. It's a lot of fun, but we found that there's enormous amount of material and objectives that we need to make sure is in this document. So this is a in-progress report. Our draft, and in fact, all these slides, which have a lot of words on them, will be on the League website, on the League page on the LPI website. So I encourage you to go down and load them onto your own computer. Don't try to scribble down things in real time now, but we do, and I'll remind you at the end, we do solicit input and suggestions between now and the League meeting, where we need to have a full report. So this is giving you an overview of where we are and some of the topics that we've been looking at. Okay. Well, here's our timeline. As I said, we started in February, where we Ben and I were identified, and we got together with the community, and some of you, I think, participated in the kickoff in February. And in March, we put together the team. And during April, we really rolled up our sleeves and got down to work with white paper submissions, information gathering, and beginning discussion amongst ourselves to start formulating how the structure of this report is going to be and what kind of contents we intend to include. Here's the members of the CLOC-SAT, Ben and I, and we've got a great team. They're all working together, and there's sort of sub-teams have evolved within this team who specialize on individual topics that we're working on. But feel free to contact any of the members, and I'll repeat at the end of this, we certainly solicit comments and suggestions, complaints if you have them, of how the report is going. Okay, we have received several community white papers. These have been very helpful. They've already been incorporated in much of our thinking and in our draft structure. So thank you for those of you who submitted white papers. We really appreciate them. Okay, where we are, here, the report structure, principal content, preliminary findings is what we're going to present today. It's mostly in Word form, and I apologize for that, but if you're really interested and want to follow up, as I say, you can find all these slides on the League website, looking under the CLOC-SAT report. Okay, the report structure, as Amy mentioned, is it will have the normal sort of introduction and why are we doing things, but then the beef of the report will concentrate on why. Why do we need additional measurements at the moon? Don't we have everything we need? Of course not. And technology is improving. There's all sorts of new wonderful things we'd like to do. So there's a lot of whys, and it really gets into how is orbital measurements linked to the overall objectives for exploration of the moon as we move forward in the next decades. Then, of course, as Amy alluded to, we have to say, well, how? What are the constraints about how we can obtain data? And I'll go through several aspects of that briefly. And then, of course, the beef, the real beef, and that mean in a good, the stuff that makes you strong, is what, and we've appreciate all the input we've gotten. We have a long list. We're putting them into groups and categories. We will not make any specific recommendations for specific instruments. That's one of the guidelines. But we will talk about what's needed in terms of capabilities as we move forward in the next decades. And then how do these three relate together? And hopefully we'll have a few example mission scenarios, not that they're things we recommend, but these are ways you can put together instruments on different platforms, different sequences, just to show a possible way of implementing some of the kinds of results that we're finding. Okay, so starting right out with, and I have about 4 slides on whys, and they all look like this, so you're going to get a little blurry. But I'll try to walk you through with a few words, sort of highlighting some of the components of what we're trying to communicate. And one is that there's the moon's place in all of planetary science is very important, and a key part of that is global measurements of specific kinds of aspects, targeted measurements, time varying measurements, a whole sequence of things that the moon offers us in order to provide the kinds of data that planetary scientists and certainly lunar scientists and explorers want to have going forward in the decades ahead. So we want to improve our understanding of some of the fundamental aspects about the moon. We want to have a full assessment of volatiles to the extent that we can obtain it from orbit. And we want to make sure that the polar regions are known to host a wide range of volatile compounds, and would like to poke at that in as much depth as can be done from remote measurements. Okay, other aspects of why are there's greatly improved characterizations of landing site in context. Landing at one site at the poles or in South Pole Aiken, you need to know where that stands in the overall context of the moon. So the character of the global and orbital measurements is essential in making that kind of extension from in situ measurements to the character of the moon as a whole, and in particular in terms of resources. So we want to know compositional and physical characterization. The impact flux, for those of you who've been following some of the really fascinating results from LRO, because of the time variation that LRO has been in orbit, we now know there's, and I forget the number, it's over 500, I think, craters have been seen to form, not in real time, but before and after. There are on the order of 500 new craters on the moon that have been documented with LRO. And we want to make sure we continue that down to different scales, in particular, those scales that are potentially hazards for surface activities. There's a potential increase in these as well. Critical resources at rover scales. Again, this has to do with many of the recommendations that we've received have to do with high spatial resolution, which is now capable from orbit. Instruments are really improving. We can make sure that those kinds of measurements are a part of the package in the future. Okay, I'm not going to read through these, but this has captured some of the a lot of the whys into some of the things that you want to do. So it links into the what's and the hows, but it is sort of the bridge between why do we need to do anything and what are some of the things we need to do to answer some of these fundamental questions. And this goes into even more detail, and I'm not going to read these because I can barely read them, but I encourage you to look at them on the documents themselves, the set of slides, because each of these really are important things that we all hold dear to us, and we want to make sure that we're not overlooking any aspect of lunar science and exploration that should be done from orbit. Okay, now how? Okay, we've got a lot of whys. There are physical constraints on hows. There are different kinds of orbits that are possible. They're the ones that we're most familiar with in general are, of course, the circular orbits that's used to do global analyses. However, much as we love those, as you know, there's gravity variations on the moon. And if you're going to want high spatial resolution, you have to get close to the moon. And gradually, any circular orbit has to be maintained, which means you need fuel, and eventually the fuel will expire. So much as we love them, we need to continue to do them, but we can't do them forever without completely replacing orbital assets on a regular basis, which is actually one of the recommendations we're going to have. But it's just something to remember that we can't put one satellite up there and it will stay there forever. Now, there are other orbits that are more long-term, and this happens with both the frozen orbits and the distant orbits. These are generally not used for global survey, but they are extremely important, especially for example, for communication. On the far side, you need a communication satellite there essentially, so you can have real-time communication. There's a variety of additional examples, but one orbit does not fit all. So there's this whole sequence of variations that we have access to. Platforms, there's polar orbits and equatorial orbits, and they can be either circular or elliptical. But the advantage of polar orbits is obvious, namely that you get global coverage. However, it takes a while to build it up, but in order to get time varying coverage, you need to have it there for a long time, so you come back into the same position and observe the same area later. Equatorial orbits have the opposite challenge, namely you have frequent temporal measurements, namely every couple of hours, if that's what you need. But you have a very limited spatial context. So these two kinds of things will fit different kinds of requirements. Continuous orbital presence of the moon relies on a variety of platforms. That should be obvious from everything I've said up to this point. But it also relies on different kinds of capabilities. The LRO class, which has multiple experiments that ideally are designed so that they can work together. You can have coordinated data with the same kind of scale and scope. So this is one of our workhorses for science and exploration, but they're typically the more expensive ones. But we definitely need to be thinking about a additional LRO class orbiter in the near future. Then there's several intermediate orbiters, and Laddie, GLAIL, Trailblazer, all wonderful examples. They do great science. They just don't last forever, and they're not intended to. They have specific objectives.
2 minutes. Sorry.
Okay. Well, thank you. You can get all these slides on the web. Okay, thank you. Okay. Let me see. Yeah. Communication. We have to have communication. This is absolutely given, no question. We have to have it. Case closed. The other point is that we need to be ready for large amounts of data. We have to store large amounts of data. LRO has produced, as was beautifully mentioned by Noah a few days ago, some of the largest amount of data available. This is going to continue, and we need to make sure that the data capabilities of storage and access keeps up with it. Okay, what? Well, there's a lot of what's, and I could be here for another 5 hours, but I'm not going to do that. But this is a lot of the key components of what we're organizing now. There's a couple of important aspects about what that needs to be addressed. Namely, we need to have instruments that are mature, that are ready to go into orbit. And that itself requires a commitment by NASA to make sure that happens, and we don't reach a point where we don't have an instrument available to fly. So this continued importance of development is central because technology is improving and we can do wonderful things that we haven't done yet. Okay. Volatiles are a key and will continue to be a key as we move forward. Near-term coverage and resource characterization are central to volatiles. And let's see. Global context, obviously, yes, I know. I see you, Greg. Okay, that's all right. Okay. Critical long-term things we need to make sure happen, and scale. I've already mentioned this is important. We have now, and these are the last two. What we're preparing is, okay, there's so much in why, so much in what, so much in how. The job that the committee is doing right now is getting them all together, trying to get them into a coherent manner that is useful to the community. And example mission scenarios. Here's my last slide, I promise. We encourage feedback and to do feedback. If you've memorized everything I've said, fine, send us feedback immediately. If you haven't, go to the League site that's on the LPI site. You can download these. Please give us some feedback by the end of the month because we have only a few weeks to prepare a full report that we will present at the next League meeting. And that is the end.
Thanks so much, Carly. Thanks to you and Ben and the rest of your team for this huge service to the community. We've all been worried about that time that will eventually come when LRO will be no longer. So thank you very much.